Hello everyone, and thanks for watching my videos. In this video, we're going to be going over how to assign the molecular geometry of covalent systems or covalent molecules. As I described in my previous video about laws of structure and how to draw laws of structure of covalent molecules. The next step after you draw laws of structure or laws electronic of structure is to assign the molecular geometry and understand how the arrangement of these electrons that we described in laws of structure are basically going to be represented in a given molecule as a 3D structure. Because remember, at the end, the chemical reaction is happening in 3D. Everything is happening in 3D in our life. So at the end, you need to understand where the bonds is going to be aligned in which, again, directions, where the lone pairs is going to be aligned in what directions. So, because at the end, the chemical reaction is going to happen by these electrons, as I mentioned before. It's a bond breaking, bond forming. You break bonds, you form bonds. And the electronic arrangement is going to matter in the chemical reactions. And it's also going to matter in the geometry of the molecules and how this will affect the polarity. When you say a molecule is polar versus molecule is non-polar, that is going to be affected by the molecular geometry and the interaction between the atoms, the electronegativity difference between the atoms. So without further ado, I hope you enjoyed the video. So this video is targeting the molecular geometry of covalent molecules and how can you assign successfully the molecular geometry of a given molecules using lowest electronic dot structure. Thank you.
These are the different cloud geometry that a covalent molecule can take. A covalent molecule can be a linear. A covalent molecule can be trigonal planar. A covalent molecule can be tetrahedral. A covalent molecule can be trigonal bipyramidal or octahedral. Who's going to tell us what? Who's going to tell us how they're going to exist? Laws of structure is going to tell us if they're going to be in linear, it's going to be trigonal planar, it's going to be tetrahedral by the charge cloud. Laws of structure basically is the main fundamental of the covalent bonding. You cannot write any covalent molecule without going through laws of structure fundamentals. So these fundamentals that we're covering here will apply to any covalent molecule, big or small. It will apply to macromolecules as long as it's covalently bonded. So what are the steps that you will follow to draw laws of structure for any covalent molecule? Imagine the covalent molecule coming, the atoms are coming with their electrons. These electrons are coming to barium. These electrons are valence electrons. So each atom coming with its own valence electron, it's all going to be shared in terms of total valence electron. So you have what's called total valence electron between the atoms in the molecule. So how you determine the total valence electrons? Not all of these electrons will be shared in bonding. Some of these electrons will be non-bonding electrons. In order to write the correct laws of structure, you have to follow these steps in order. Do not jump any steps. Follow them in order. So what are the steps? Step one, count the total valence electron. How you count the total valence electron? By looking at the atoms in the periodic table. You know exactly what atoms you have in the molecule. When it says what is the total valence electron for carbon dioxide, you will look at the periodic table, you will see carbon is in group 4A. That means it has 4 valence electrons. Oxygen is in group 6A, has 6 valence electrons. So for carbon dioxide, you have 4 from carbon, 6 from oxygen, and you have 2 oxygen. So that would be 4 plus 12. That will give you total 16 electrons. So what you have right now in your total electrons is 16. This is the maximum numbers that you have. You cannot exceed it, and you cannot have less of it. The molecule at the end